Section 4B, using the Pythagorean theorem to classify triangles. So here we have a triangle with three sides, and the question is it a right triangle? And we already know that if we take the two legs of a right triangle, square each of them, add them together, that sum will be the same as the hypotenuse side squared. So that means if we have a right triangle, we can use this. But it also means that if we do this and it is a true statement, then you can conclude that the triangle is a right triangle. The key to this is knowing what side is the longest side, in other words the hypotenuse, because that's going to be on a side by itself. So here you see that the 32 is the longest side. So that is the hypotenuse. And we're going to put that by itself and we're going to square it. On the other side, we're going to take the two legs and square them and add them together. And what that gives us is on the left side, when we square them and add them together, 1056.25. On the other side, 32.5 squared is 1056.25. It's a true statement. So we would say, yes, it is a right triangle. Another form of a classification is to say, is it a right triangle? And if it's not, is it an obtuse triangle or acute? Now, obtuse triangle means that, well, a right triangle means you have one angle that measures 90 degrees. If you have an obtuse, it means you have one angle that's greater than 90 degrees. So 100, 110, and so on. If it's an acute triangle, all angles are less than 90. So if we take a look at number 11, we have a picture. We don't know if it's a right triangle or not, but we apply the Pythagorean theorem. We can learn a lot. I'm going to show you a shortcut at this point, and that is that sometimes it's hard to see with the radical in there what side is the longest. But we do know that when we use the Pythagorean theorem, we square every side. So why not at this point just square every side we have? Because something neat happens. 4 squared is 16, 6 squared is 36, and when you square a root, they cancel. So right now we know that that length is squared is 56. So now you can easily see which side is longest. The 56 is. So if I go the two legs, and I've already squared them, so I'm just adding them together, does that sum equal 56? Now, when we add 16 and 36, we get 52. That does not equal 56. So it's not a right triangle. So the natural question is, what is it? Is it obtuse or acute? Now we have stated that the two legs added together is 52. And that's not the same length as the hypotenuse. Now there's a couple formulas you can use in this case, or some descriptors. You can write this down and say that if you have the two legs squared and added together, if it is greater than the hypotenuse squared, then this is called an acute triangle. If you do the two legs, square them and add them together, and it's less than the hypotenuse squared, then it's obtuse. You can use that as a reference sheet, that's fine. What do we have here? Well, we have the sum of those two sides squared being less than that amount, less than the hypotenuse squared, which is this situation, so it's obtuse. And our last type of question would be to have information given to us in number form, not on a picture. We're going to use that shortcut we just talked about by just squaring each of our terms, each of our sides, because when we have radicals and we square it, we just get the number inside. The 17 squared is 289. When we look at this, we see that the 289 is the longest side, therefore the hypotenuse. So the sum of the other two must equal that in order to be a right triangle. But we actually get 225 on the left side, and that is not equal to 289 So we would say no, it is not a right triangle.